Bismillahirrahmanirrahim. How are you, students? Today we will study physics, grade 11. I am your teacher Aftab Alam. Unit number 9. Unit number 9, physical optics or geometrical optics. Today topic is interference in thin films. Interference in thin films. Now, before going into detail of interference in thin film, we will study the condition for interference of reflected waves. The condition for constructive and destructive interference. The condition for constructive interference is that path difference is equal to d sine theta for constructive interference, and this d sine theta is equal to m lambda. This is for constructive interference. Now for destructive interference, path difference is the same. D sine theta is equal to m plus 1 by 2 lambda. M plus 1 by 2 lambda. So we should remember these conditions before going into detail of next topic. Now, thin interference in thin films. Thin film interference in thin films occurs when light waves reflecting interference in thin films. The thin films interference in thin films occurs when light waves reflecting off the top and bottom surface of a thin film interfere with one another. This type of interference is the reason that thin films such as oil or soap bubbles form colorful pattern. For example, if you consider this a layer of thin film. This is oil or soap. Oil. Thin layer of oil. And this is a layer of water. Light ray coming from this side. A part of it is reflected. This is incident ray. A part of the incident ray is reflected and a part is refracted. And then reflection take place from that bottom like this. So when these two light rays come into our eyes, it produces interference pattern or color pattern due to the path difference. Now in this case, this is incident ray. It hit the oil surface and will reflect. Some of its portion is reflected and some of its portion is refracted, and when it bounces back from the second layer, a phase difference will take place between these two reflected and refracted ray 1, ray 2. So when this light ray is reflected, ray 1 is reflected and ray 2 is refracted, and then it reflects from the bottom of oil and from the top of oil. So when it is reflected from the top, a phase change of lambda divided by 2 will take place. A phase difference of 180 degree will be produced, which is equal to lambda by 2. In term of wavelength, phase difference will be equal to a phase shift will take place, which is equal to 180 degree, and half of the wavelength and equal to half of the wavelength will take place. And when these two light rays interfere with each other, either constructive interference will take place or destructive interference will take place. If the path difference is integral multiple, path difference is integral multiple is equal to integral multiple, then constructive interference will take place, otherwise destructive interference will take place. Now if you can see, this is the incident ray, the bluish incident ray. Some of its portion is reflected from the top of the oil, from the top layer, and some is reflected, and after that refraction will take place. So when these two light rays come in our eyes, they interfere either constructively or destructively. Here a phase change of lambda divided by 2 will take place, and when it is reflected from the bottom, no phase change will take place. Now here the question is, why this interference of light take place? A substance that is normally clear and colorless can appear to give off an array of colors when it is found in a very thin film. The condition for interference is, you see the color pattern of peacock feathers, it is due to interference of light waves. So when the wavelength of light is equal to the width or less than, wavelength is less than the width, then interference pattern will take place, interference phenomena will take place. If wavelength is less than the width from which reflection take place, so if this condition is satisfied, then interference pattern will take place, otherwise not. Now if the path difference is integral multiple of wavelength, path difference between two light ray, path difference between two light rays which interfere constructively or destructively, if the path difference is integral multiple of wavelength, integral m means m lambda, m is equal to 0, 1, 2, 3 and so on. If it is integral multiple of wavelength, then constructive interference will take place. But if path difference is half integral multiple of wavelength, then destructive interference will take place. It can be seen that the path of one light ray with respect to the other light ray is differ due to reflection from the top layer of oil and bottom layer of oil. Simply you can say that path difference will actually depend upon thickness and nature of the film. I will write path difference depend upon thickness and nature of film. First, thickness and nature of film, thickness and nature of film. And second, Ingelap incidence. Ingelap incidence. Ingelap incidence. Now if you can see, this light ray and this light ray is shown in crest and trough palm. Is shown in crest and trough palm. This is trough and this region is called crest. This is crest, this is trough. So it is shown in that way. It is reflected from this edge, from this point, and this light ray will be reflected from the bottom. When they both comes in our eyes, they produce interference pattern. If crest interfere with the crest falls on crest, and trough falls on trough, they will interfere either constructively or destructively. If crest falls on crest, like in this example, it will interfere constructively. If you look here, they will interfere destructively because crest fall on the trough falls on the trough. So for the destructive interference, the condition is a path difference, which is d sine theta, will be equal to m plus 1 by 2 lambda, and d sine theta will be equal to m lambda. Now, depending upon thickness of the film, interference pattern produced depend upon thickness of the film and the light waves that reach your eye, whether it is monochromatic or not. And the Ingelap also on the Ingelap incidence, the angle at which it fall on the surface. Here the crest falls on crest and trough falls on trough in the first diagram. It is from the top region, it is from the bottom region of the oil, from the top layer of oil and from the bottom layer of oil, and they will interfere constructively. Here in this case they will interfere destructively because crest fall on trough. Now why does it happen? First, if you look, numbering is given 1, 2, 3, 4, 5 and 6. We will explain. When light ray hit the surface, when light ray hit the surface, some is reflected. 2 means some of its portion is reflected, and some of its portion, some is transmitted through the new medium. This is water, this is new medium. Oil, sorry, this is top oil, this is water, and this is air. We have 3 medium: air, oil, water. So some will be reflected from the oil, from the top layer of oil, and some is reflected, and then reflection will take place from the bottom. Here in this case, the first one, a phase shift of 180 degree will take place in term of angle. In term of wavelength, a phase change of lambda divided by 2 will take place. Here no phase change will take place. The reason is oil is denser as compared to water, so reflection will take place from the rare medium and here the reflection will take place from the denser medium. So when light ray is reflected from a denser medium, a phase change of 180 degree will take place, and if it is reflected from the rare medium, no phase change will take place. At the next barrier, some light is reflected and then refracted through the first layer, and some is transmitted. Now things to be considered: the type of reflection experienced by the light waves at each boundary depend upon the refraction indexes of the two mediums. Hard medium, reflect off a medium with a higher refractive index, resulting a phase shift of 180 degree. If reflection, if a light ray is traveling in a rare medium and hit the surface of a denser medium, a phase change of 180 degree will take place. When a ray travels from a medium of lower refractive index to a medium of higher refractive index, it undergoes a phase change of 180 degree after reflection. This is the first one. The second is soft reflection. Reflection from rare medium. No phase change will take place. No phase shift will take place. Reflect of a medium with a low refractive index, resulting in no phase shift. Means phase difference produced is 0, and here a phase difference of 180 degree will be produced when reflection takes place from harder medium. Why does thin film interference resulting in an array of different colors? Since each color of light has a different wavelength, different thicknesses of the film, layer correspond to different colors, interfere constructively or destructively depending upon their path difference. This creates a rainbow like effect as the thickness of the film changes at different points. Now, no phase change in reflection. Light reflected from the bottom of film. From the bottom, it means that when light ray reflected from a rare medium traveling in a denser medium, when there is no phase coherence, constructive interference occurs. Now, things to be considered. Done. Destructive interference. You can see, if reflection takes place from a denser medium, a phase change of 180 degree will take place. From a denser medium, a phase change of 180 degree will take place. Means lambda by 2 is equal to, in term of wavelength, it will be equal to lambda by 2. For destructive interference, the condition in your book is d sin theta is equal to m plus 1 by 2 lambda. Now, if light ray interfere constructively, no phase shift between waves, there will be no phase change. There will be no if two ray interfere, their phase shift will be 0 degree. And the condition is d sin theta is equal to m lambda. D sin theta is equal to m lambda for constructive interference. Why does thin film interference result in array of different colors? Since each color of light has a different wavelength, different thickness of the film layers corresponds to different colors, interfering constructively or destructively. This creates a rainbow-like effect as the thickness of the film changes at different points. Thickness is not uniform. When thickness is not uniform and you have different lights, so they will interfere or respond in a different way. Now, in this case, if a wave enters a boundary from a medium where the speed is lower, it will reflect in phase. For example, if crest is traveling in this direction and it is reflected as a crest, means light ray traveling from denser medium and hit the boundary of rare medium, no phase change will take place. But if A light ray traveling from rare medium and it reflects from a denser medium, a phase change of 180 degree will take place. Now Michelson interferometer. Michelson interferometer. Now the instrument can produce both types of interference fringes, circular fringes of equal inclination at infinity and localized fringes of equal thicknesses. Michelson interferometer is an optical instrument. It is used to study the interference of light waves and find its wavelength. Michelson interferometer is an optical instrument. Optical instrument. First, it is used to study interference of light. Interference of light. Interference of light, and to calculate the wavelength. For lambda, we use this equation of Michelson interferometer. The principle of Michelson interferometer is based on the division of amplitude. Working principle is division of amplitude, usually by partial reflection and transmission of light at the boundaries of the two medium. Again, the principle of Michelson interferometer is based on the division of amplitude, usually by partial reflection and transmission of light at the boundary of the two medium. The essential part of the interferometer devised by Michelson are the two plane mirror M1 and M2. For example, come to next page. Now you can see the given diagram. It is the detector. It is the source. Light ray is reflected, half of portion is reflected in this direction and half is reflected. When it comes, it travel in this direction and it will travel in this direction, and here interference pattern will be produced. It's beam splitter. This is source, this is detector, this is path compensator, this is fixed mirror, and this is movable mirror. Now if you can see, this is source of light. It is beam splitter. It split the beam of light in this direction, and it will also reflect in this direction also. This is called path compensator. So the light ray reflected here goes again. In that duration of time, this light ray reaches also at the same point, and here interference pattern will be produced. This is fixed mirror. This is movable mirror. With the help of path compensator, you can convert constructive interference into destructive interference. Now, condition for interference. If the path difference between the two parts of light is either 0 or integral multiple of wavelength, then constructive interference will take place. Now, if this light ray interfere with this light ray, both these two types of light rays can be obtained in Michelson interferometer. If they interfere destructively, for example, here the crest and here is the trap, then no the wave will be produced. This is the resultant one. No light ray will be produced. Here it is crest, here it is crest. When they interfere, constructive interference will take place, and interference pattern will be produced. Now here the light ray will interfere destructively. Here the light ray will interfere constructively. Here in some places constructively and in some places destructively. But most response is destructive, back to destructive interference. Here constructive interference will take place and here destructive. Now this is the incident light ray. Reflection take place from the topmost point. Half is reflected and half is refracted. Half is refracted. When these two light ray comes in our eyes, interference pattern will be produced depending upon the path difference. If the path difference is integral multiple, constructive interference will take place. If path difference is half integral multiple, destructive interference will take place. Thank you, students. Now, for constructive interference, the path difference is a half integral multiple. Now, students, remember that if path difference is half integral multiple, then destructive interference will take place. If it is integral multiple of wavelength, constructive interference will take place. Thank you, students. Wish you best of luck. Allah Hafiz.